Chapter 1.6, Limits Involving Infinity. It's kind of broken into two parts. One part where the y values, the function values, are going to infinity or negative infinity. So that's vertical thinking. Part 2 is about x going to infinity, horizontal asymptotes and stuff. Limits involving infinity are useful in probability and theoretical statistics. We use them in Calc 2 a lot. They're useful in engineering. You wouldn't think things can go to infinity in engineering, but it is actually helpful sometimes to think about what happens to a system as time goes to infinity. Useful in physics as you get infinitely far away from something, all kinds of stuff like that. Our first big question is, how big can you make 1 over x? And for now, we'll just consider positive x values. Think for a sec, what's the graph of 1 over x? It's a hyperbola like that, right? Never quite touches the x-axis over here, never quite touches the y-axis over here. For x less than 0, it looks like that, but we'll get back to that later. Is there a way we can guarantee that 1 over x is bigger than 10, for example? Can we do that by saying, well, if you keep x within this range, then I guarantee you that 1 over x will be bigger than 10. What range do I need to write here, or domain, will keep 1 over x bigger than 10? Well, we're not allowing 0, right? So we'll use an open interval there. And I would say anything bigger than 1/10, we could even allow equality here. So if x was 1/10, then 1 over x would be 10. And if x was anything smaller than 1/10, then 1 over x would be bigger than 10. Is there a way we could guarantee 1 over x is bigger than 1,000? What interval would I have to keep x restricted to, kind of a tolerance, to guarantee that 1 over x is bigger than 1 over 1,000? Well, again, we won't allow 0 itself, but you'd say maybe as long as x is smaller than 1 over 1,000, then 1 over x will be bigger than 1,000. So now 10 and 1,000, I just kind of picked those. They're kind of obvious numbers. But are we satisfied that if you picked some number here and said, can you guarantee that 1 over x is bigger than that, I could come up with a tolerance interval around for x that would guarantee that 1 over x was bigger than that? It's a pretty straightforward kind of pattern between this and that, right? So I think we're satisfied that we can make 1 over x stay above any particular value we want. So satisfied that we can make 1 over x stay above any specified at or above. We'll allow equality. At or above any specified y value, a y level we choose. By keeping x close enough to 0. But still positive. We're just dealing with the positive numbers here. So because we're satisfied with that, we can say that the limit as x goes to 0 plus, we're just going from the plus side, of 1 over x. If I had asked you this, what would, last chapter or last section, what would you say? You'd say, oh, that limit does not exist because it shoots to infinity. And that's still true, but now we're going to write it from a different perspective. Instead of emphasizing that the limit doesn't exist, we're going to say that the limit is infinity. So we're going to write an infinity here. That's a vertical infinity, right? This function is shooting off to infinity. But even though I'm writing the limit equals something, it still counts as does not exist. So we're changing the emphasis from does not exist, the infinity kind, to the limit is infinity, which still counts as does not exist. All right, so that's for the one-sided limit from the positive side. How about the limit as x goes to 0 minus 1 over x? Think back to this graph. What would you say that that limit is? can you guarantee that 1 over x stays below any particular level you choose, like 10 or negative 10, negative 1,000, negative 100 gazillion, and I mean we can do the same kind of pattern we did here, and so we'd say, well, that's diving toward negative infinity, which still counts as d/e. So when we have limit theorems that say if the limit exists, here these do not satisfy those theorems because the limit does not exist, and we're emphasizing up front it's this kind of does not exist. So what about the two-sided limit here? The limit as x goes to 0 without a plus or a minus of 1 over x. What would we say about that? Well, it's obviously d/e. The two sides don't match, right? So I can't say it's infinity. I can't say it's in minus infinity. So we can't say it equals infinity because of the left side. We can't say it equals minus infinity. We can't say it equals plus or minus infinity because the limit still has to be just one number. I mean, infinity isn't really a number. So overall, we just say the limit does not exist. So we can't say it's infinity, even though one of them is going to infinity. So that's for 1 over x. What's another interesting function that behaves kind of like that? How about what's the limit as x goes to 0 of 1 over x squared? Take a sec to draw 1 over x squared. It looks by eye a lot like 1 over x, but instead of being negative over here, the negatives get squared, and so you get positives. So what would you say is that limit? So, well, we could break it down into both the two sides separately. The limit as x goes to 0 plus, we'd be looking at that behavior, and that's shooting off to infinity as well. How about the limit as x goes to 0 minus? It's looking like that, which is also infinity. So what would you say overall? The limit as x goes to 0 without a plus or a minus is just in plain infinity because the left and right sides agree. But it still counts as d/e. So what tends to cause this kind of behavior, and what's a name for it? Well, this kind of behavior is called a vertical asymptote. And here our vertical asymptotes were both at x equals 0. We could have a vertical asymptote somewhere else. What tends to cause vertical asymptotes? What tends to cause functions to shoot to infinity or negative infinity? Both 1 over x squared and 1 over x count as vertical asymptotes. The vertical asymptote doesn't have to be the same direction. It can be opposite directions. Let's see. So what causes these? Think about what kind of things would cause that. The big one is divide by 0, right? Which is what was going on here. Some people would say tangent. The tangent function keeps shooting to infinity, which is basically divide by 0 because the cosine on the bottom is 0 every now and then. So divide by 0 including tangent. Because tangent is sine x over cosine x. What else? Log of 0 is the other big one, because log of 0 also shoots toward negative infinity, although it actually goes to 0 to negative infinity very slowly, which is kind of weird. But you could still say it's going to infinity, so it must be going kind of quickly, right? The other thing we're often worried about, square root of a negative, that causes complex numbers but doesn't cause things to shoot to infinity, so it's not really an issue here. So we'll say that separately. So square root of a negative is not an issue here. All right, so that's a quick introduction to limits being infinity, which still counts as D&E.